Hello everyone. In this video, I'm going to go through how to set up Git and GitHub for an IntelliJ IDEA Java project. I'm going to do this in two ways. First, I'm going to do it using Git in the command line. Next, I'm going to go through and do this using Git and the version control tools built into IntelliJ. So let's begin. On the left here, I have a terminal running on my Mac. If you're running on Windows, then you'll be running a command prompt. As I go through this video, I'm going to tell you the commands to do this on both Windows and on Mac. But do know that right now, as you can see from my prompt, I'm running on a Mac. On the right over here, I just have Atom, a simple text editor that I'm going to use to take notes. So first and foremost, let's head over to IntelliJ and make a new project. I'm going to call this project Hello World GitHub, just because I already have a few Hello World projects already. Note where this project location is. For me, this is in my user home folder, Idea Projects, Hello World GitHub. Let's get our Hello World set up fairly quickly. I'm going to right click on the source folder, new Java class, and I'll just call this main. In main Java, I'm going to quickly add a main method and a simple print line to say hello. I'll save this, run it real quick. And it looks like everything executed as planned. Okay, great. So now the goal is to take this Hello World GitHub project and convert its folder into a repository. Let's take some notes on how to do this. First off, what is version control? The quick definition I like to give is a tool for tracking changes. There are a lot of different tools that you can use for version control. In this video, we're going to use Git, but there are a few other options out there. For example, CVS, Mercurial, SVN, or Perforce. Git is just one tool you can use for version control. Let's next talk about what is a repository or what's a repo. So I have a folder on my machine called Hello World GitHub. You can see the path right here. It's in my home folder, in my Idea Projects folder. So I'm over here on my terminal, and you can see I've already CD'd into my Idea Projects folder. I'm going to CD into my Hello World GitHub folder. Okay, great. So Hello World GitHub is a folder or a directory in Unix terms. All right, it's just a folder. If I want to make Hello World GitHub a repository, then I need to use a tool like Git and track its changes under version control. So to make this folder a repository, or repo for short, I need to put it under version control. So right now, if I run the command Git Status, this is going to tell me the state of my repository. But based on what I just wrote in these notes, Hello World is just a folder. It's not actually a repository. And that's what Git Status tells me. It says, fatal, not a Git repository. Okay, so how do we make this folder, Hello World GitHub, into a repository? Well, we run the command git init. Init is short for initialization, and this is going to initialize an empty Git repository in this folder. So now, Hello World GitHub is in fact a Git repo. If I run Git Status again, I'm going to get some different output this time. We see on branch master, don't worry about branches right now. No commits yet, don't worry about commits right now. I'll talk about them soon. And we have some untracked files. Okay, so here we have the .idea folder, hello world github.iml file, the out folder, and the source folder. Okay, Git is saying, hey, I detect these files and folders in this repo, you're not tracking the changes in them. If you want me to track the changes in them, you need to add them using this command. Okay, great. Let's do that. For now, we're going to just add all 4 of these files and folders, and then later we're going to come back and learn about some best practices. For example, it's not a good idea to put this out folder under version control. If we look at this out folder in IntelliJ, we see that it contains our .class files for our Java project. These are intermediate build files that are not necessary to put under version control. In fact, in general, we only want to put our source code and our project or environment configuration files under source control. Anything like a class file or an out file or an object file, anything that's an intermediate build file, we don't want to put up in version control. So for now, we will put our out folder in version control, but we'll come back later and use a Git Ignore file and not put the out folder under version control. Okay, so just like Git is suggesting us to do, we're going to use the git add command to add these files and folders to Git. So we'll run git add -a. The -a means all. Go ahead and add all the files in this folder and its subfolders to Git. Now I run a Git status and I get some different output. Instead, we see we have changes to be committed. We've got all these new files. So let's talk about what is a commit. My quick and dirty definition for commit is a commit is a package of changes with a label. And that label is really synonymous with a message. Let's see this in action. Let's say we want to package up all of the changes in these files, and we want to put a label on it, something like initial commit or first commit. We'll run the git commit command, git commit -m. The -m flag or option is for adding a message, and that message, like my note says, is really just a label. So I'm going to do something like initial commit. That's a pretty standard convention used for the first time you're putting all of your files in a repository under version control. I run this, I get some information about the number of files that were changed and whether those changes were insertions or deletions. All right, looks good. Let's run git status one more time. It says nothing to commit. So it looks like our commit that we just made captures all the changes in our folder, as we'd expect. So let me do a little bit more explaining of what a commit is. If you can remember back in the day, if you ran a Windows machine, you would set up something called a system restore point. Okay, this system restore point would typically have some sort of label with it, right? Maybe the date and the time and maybe something you were about to try and do you thought was kind of risky and might end up crashing your machine. You know, maybe something like upgrading to Windows Vista January 1st, some odd year. And then you'd make the upgrade, and if everything went well, you would never use that system restore point. But if something didn't go so well, you might roll back or revert to that system restore point in order to get rid of any errors you may have had in your upgrade. I like to think of that system restore point more generally as a snapshot in time. Okay, that's essentially what we're doing with this commit. We're taking a snapshot of the files and folders in our Git repo, and in the future, we might need to revert back to this snapshot because maybe we break something in our code later, or maybe we might just roll back to look at some changes. Perhaps we're collaborating on a project and someone, introduced some bug and we want to roll back and see, okay, when was that bug introduced, or how did the code execute right before so-and-so made this commit? That's really what these commits do for you. They make snapshots of your code at certain points in time. Your label or your message should really describe all of the changes since the last commit. Since we don't have any previous commits, we went with the standard message or label initial commit. Those of you who weren't Windows users, this analogy can apply to Time Machine as well. Okay, awesome. Well, now we're Git gurus, And we're going to make some changes, say, to our IntelliJ project. Let's say in main.java, we add another print line. I'm literally going to write another print line. Just make some change in this file. That way we can see how Git keeps track of changes. So I'm going to save it, head back over to the terminal, run a Git status, and look, right here, Git noticed that we modified the main.java file in our source folder. It's tracking the changes because we added main.java to our version control. Okay, great. So now we need to add this change to the staging area. And if we have other changes, we could make them now and also add them to the staging area. And once we're ready to package up all those changes as a commit, we'll run the commit command. So let's do git add. And this time, let's just add our single file. We could also do git add -a as I did before, but here's just an alternative way to use this command. Git status. Great. We see we have a change to be committed. Git commit -m. Okay, let's have a message here that describes the changes that we just made. I'll say something like add another print line. You can see how if you were working on an actual software development project, you'd probably put something in here like fix bug number 1031 or something descriptive. All right, I have one more command to show you, and then we're going to head over to GitHub. So the first one, or this next command, is Git Log. Now that we have a few commits in our repository, it might be nice to be able to see those commits in chronological order. So here you can see each commit has a unique identifier. It has an author, this is me, and a timestamp. Here indented is our message that we put in with a -m and a string. I do have one more thing I realized I want to show you. If you're on a Windows machine, go ahead and type dir space /a. If you're on a Mac or Unix machine like I am, go ahead and run ls space -al. And let me type that command over here. So that's dir /a or ls-al. What this is going to do is give you a listing of all the contents of the current working directory, including hidden files. This is the important part here. When we ran git init created this special hidden folder called .git. This is essentially where Git is keeping track of all of these changes and all of these commits, and soon all of your remotes that you're going to add so you can push your code up into the cloud. All right, that's our next step. Time to set up a GitHub repository. So right now we have a local repo. We want to push this repo up to the cloud. So we need something called a remote repository. There are a few different sites you could use for your remote repository. In this video, we're going to use GitHub. So let's head over to GitHub. Go ahead and make an account if you haven't already made one. Sign into your account and you should get to a home page for your profile that looks something like this. There are a few different ways to make a GitHub repo. Here's just one way. Click on repositories. There'll be a nice big green new button. Click on the new button. You'll be taken to this screen to create a new repository. So remember, we're making a remote repository. This repository is going to live in the cloud or live on a GitHub server somewhere. Okay, this is a different repository than the local one we've been working with on our machine. So we get a chance to name this remote repository. We can name it really whatever we want. It doesn't have to match the name of our local repo. So remember, the name of my local repo is Hello World GitHub. Now, I'm going to name my remote repo the same thing, but it doesn't have to match. Go ahead and leave everything else here the same. No need to change any of these radio buttons or checkboxes. Just leave it at the default and hit Create Repository. You should see a screen that looks like this. GitHub is really nice, okay? They're going to provide you with some suggestions for how to get your local repository up into this remote repository. So let's take a look at some of the suggestions they have. The first one is create a new repository on the command line. If you look at these commands here, we've got git init, git add, git commit. We've already done that. We're pretty much Git gurus by now. This Git Remote Add, we haven't done that yet. The next one says push an existing repository from the command line. And this is us, right? We have an existing local repo we've created from the command line. We've added some files, we've added some commits. Now we're ready to push that existing repo up into the cloud. So we're gonna run these two commands. Let's take a closer look at this first one. So Git Remote Add. We're going to add a remote to our local repo. This will be kept track in the .git hidden folder that I just showed you. After remote add, there's a name here. This is an alias. Typically this is origin, but you could change this name if you wanted to. And then we have a URL. This URL is unique to your repo. And you can tell this by looking at both my URL and your URL. gsprint23, that's my username. So you're going to have a different URL even if you named your repository the same as mine. This is going to be your username here, and you have to use your URL, not mine. You won't have write access to my account, but you do have write access or push access to your account. So let's go ahead and copy this first line. Let's paste it. Looks good. Now we've established a link between our local repository and our remote repository. I want to emphasize that no files have been transferred. All of your files are still in your local repository and they're not in your remote repository. This is still an empty repository up in the cloud. The next step we're going to do is push those files from our local repo up to our remote repo. So let's copy this next command here and paste it. We're going to see some output here, compressing objects, writing objects. This is really transferring files from your machine up to the GitHub server. So let's break down this Git Push -u origin master. So the -u flag here is really making a shortcut for us so that we don't have to type Git Push -u origin master every time we want to push our code up to the cloud. We can now type just Git Push, and it'll always go to our remote named origin and its master branch. Like I said earlier, don't worry about branching right now. It's not needed for this video. All right, so let's go back over to the browser and see if those files actually made it up into our remote repo. Right now it looks empty. I go ahead and refresh, and there are all of our files and folders in our local repo, in our cloud repo. That's awesome. All right. Right now would be a good time to pause the video, head back over to IntelliJ, make another change to our main.java, add another print line, modify the string, whatever you want to do, just make a change, save it, and go through the whole process of adding the change, committing the change, and pushing the change. And remember, now when we run push, all we have to do is type git push. All right, I want to show you a few more things related to GitHub. Let's say we head over to our source folder, we go to main.java, and we edit main.java in our remote repo. Click the little edit here. Let's say I add some exclamation marks. That's great. make a change. I can make a change in the remote repo, commit that change, and then pull that change down from the GitHub server to my local repo. So right here, GitHub's prompting me to add a label, add a message for this change that I'm about to commit. So I'm going to say something like add exclamation marks. Commit changes. Okay, now main.java in my remote repo has a commit, has a package of changes that my local repo doesn't have. So I'm going to head over to my local repo and I'm going to run git pull and I'm going to pull those changes down. So look here, it detected that main.java had a change. If I head over to IntelliJ, look, it just auto updated. That's pretty cool. Imagine if you're collaborating with someone, say, in Europe, right? You can both work on the same code base and collaborate via GitHub. All right. Next thing I want to show you. Remember earlier when I talked about best practices include not putting build files like .class files under version control? Well, now it's time to remove that it's time to remove this folder here, the out folder. We don't want to put this under version control. It really shouldn't be up here. Let's open a new tab and type GitHub Git Ignore. There are two really important links that show up in this search result. Let's start with the second one, GitHub help, ignoring files. Here's a really quick read that I encourage you all to take some time and look through. This is GitHub explaining Git Ignore files. I'll give you a quick summary. If you have a file in your GitHub repo called .gitignore, it has to be called exactly that. Git knows to look for this file and ignore any files or folders listed in the .gitignore file. Now, we can make our own .gitignore file and put in the out folder, and Git would ignore the out folder. Now, there's actually a better way, and that's the first search result that came up here. GitHub has its own repository called Git Ignore, where there is a collection of useful .gitignore templates. For example, let's take a look at java.gitignore. Take a look at that first entry. This here represents a regular expression for ignoring all files that end with .class. Now, we want to ignore not just all .class files, but we want to actually ignore the whole entire out folder. If I look in here, I don't see any entry for the out folder. So let's back out a level and keep poking around. Here's some other programming languages and their Git Ignore files. If we head up to global, we'll see some more Git Ignores that can be used for different IDEs or different tools. Right here is JetBrains.gitignore. JetBrains is the organization that maintains IntelliJ, which is this wonderful IDE we're using here. If we look at the first line, it says JetBrains.gitignore covers JetBrains IDEs, IntelliJ, RubyMine, PHPStorm, AppCode, PyCharm, CLine, Android Studio, and WebStorm. So this is great. This is exactly what we need. We're using IntelliJ. So you can see there's some pretty advanced entries in this file, ones that we don't have to write ourselves, we can just use. And look, right here, line 47, there's that entry to ignore the out folder that we were hoping for. We could have written this ourselves, but we're going to use this Git Ignore because look at all these other entries that we're going to get for free. That's awesome. Thanks, JetBrains. All right, click on raw. This is going to give you the raw text from the JetBrains.gitignore file. Now, depending on what browser you're using, there's a few different ways you could download this file. A really simple way, just right-click, Save As. If you don't see a Save As here, don't click Save Page As. That would be the wrong thing to do. Instead, something simple I'd recommend is Command A or Control A to highlight all the text, Command C or Control C to copy it to the clipboard, and then just paste it in a new file. Use any text editor or IntelliJ. That will work just fine. So I'm going to save as. Remember, the name of this file has to be .git ignore. It has to match that exactly. So I'm going to save this as .git ignore. Take off the format. I definitely don't want Max sticking a .txt on the end there. And I'm going to navigate to my Hello World GitHub top level folder. Here I am. I'm going to save it. Yes, Mac, that's okay. Using a dot. Once you get it saved, just do a double check real quick. Go ahead and do an ls-al on Mac or a dir/a on Windows and make sure you see that .git ignore file. Remember, it has to be named exactly this. Looks like I'm good, and I hope you're good as well. All right. Remember a few minutes ago, maybe more than a few minutes ago, when we ran git add-a. We've already informed Git it should track all the files in this folder. So even though we've added this git ignore, it's not going to quite work until we tell Git, hey, remove all the files you've been tracking, and then let's add them again. Then it'll magically work. So here's a rather long command, but an important one, but not one you're going to use very often. It's kind of the reverse of git add-a. We want to remove all of the files from version control in Git. So we're going to run git rm for remove. Make sure you have the Git in front. We're not removing files on the file system. We're just removing files from tracking in Git. -r for recursive. --cache, so we remove everything. And dot for the current directory. Great. Now Git is no longer tracking any files in our repo. I run Git Status. And here are the untracked files and folders that Git recognized. Note we have a new file here, .git ignore, but also note something really important. What is not here? The out folder. The out folder is not here because Git is reading the git ignore file and ignoring the out folder, which is exactly what we wanted. Thank you, Git ignore. This is great. Let's run git add-a, git commit-m, something like add git ignore file, git push, now I'm going to head over to my repo. Note, I had the out folder here in my class files. Refresh, and now it's gone. This is a repository that looks better. This follows more best practices for GitHub version control. All right, that was a lot, but we got through it. That was a complete example of setting up a local Git repo and a remote GitHub repo for a basic IntelliJ IDEA Java project. Now it's time to do this whole thing again, but instead of using the command line, which worked really well for us, we're going to use the graphical user interface tools in IntelliJ. Don't worry, this isn't going to be as long as doing it from command line because we've already learned a lot about the purpose of version control, Git, and GitHub. So here's what I'm going to do. I'm going to close Hello World GitHub, and I'm just going to make a new project for simplicity. I'll call this Hello World GitHub GUI. How's that? So real quickly here, I just got a hello world running again. Everything seems to be good. All right, now we're going to initialize a Git repo for this hello world GUI project. We're going to add some files. We're going to make a commit. We're going to set up a remote and do this all without touching the command line. So I'm going to head up to the IntelliJ IDEA menu. There's an entry here called VCS for version control system. And we've got a lot of options here. I want to emphasize that all of the actions I'm going to take in this video have other ways they could be done. For example, with keyboard shortcuts or down here in the lower left panel. This is just one way to do it. So VCS, I'm going to choose Enable Version Control Integration. It's going to prompt me and say, hey, what version control system do you want to use? Looks like I've got a few options that come packaged with IntelliJ. I'm going to choose Git, hit OK. And this is like our Git init. In fact, down here, we see created Git repository in my absolute path to this project, Hello World GitHub GUI. All right, that's great. Now we have a new tab right here, version control. I click on it, and this is kind of going to give us a graphical user interface for Git status. I expand unversioned files, and I see I've got 6 files here that are unversioned. Note that there is a Git Ignore file here, but if you look at this path, this is in the .idea IntelliJ config folder. This is not a top-level Git Ignore file. So we still need to add a Git Ignore file if we want to have Git, for example, ignore the out folder. All right, I'm not going to do that now for the sake of time. I think you know how to do it now based on our previous project. I'm going to highlight all of these files, right-click, Git Add. Note there's also a keyboard shortcut to do this. Okay, note how those moved out of the unversion list into the default change list. This is like our staging area. Now I want to commit all of these changes in this change list. So there's a keyboard shortcut, Control K on Windows, Command K on Mac. You can also do it from right-clicking, going to VCS, or hitting this nice little check mark. So here's a dialog for essentially the git commit -m command. There's a lot more features here, obviously, like we can compare versions and things. But here's the box we're most interested in, where we can enter a commit message. So I'm going to say something like initial commit, because this is our first commit in this new project. I'm also going to uncheck all of these before commit boxes. It's unnecessary for our demo here. I'll hit commit. Looks like 6 files were committed under the message initial commit. Awesome. We only have one more thing to do, which is we need to set up a remote. So let's go back to GitHub, make a new repository. I'm going to copy this URL because that's all I need for IntelliJ. Before we would run these commands in the command line, but remember, in this project, we're doing all of our Git work from the GUI. So just copy this URL and leave it on your clipboard. We're going to use it here. I'm going to go up to VCS. Under Git, there's an option to push, also a keyboard shortcut. All of our remotes will be listed here, but we don't have any remotes. So IntelliJ is smart and it's prompting us to define a remote. Go ahead and click Define Remote. It prompts you for that alias. We did this from command line. And a URL. Go ahead and paste that URL. Hit OK. Here's our commit. We're going to push. And we push. says push successful, push master to new branch origin master. All right, let's go back, refresh the page, and look, here's our local repos, files, and folders pushed up to our remote repo without ever touching the command line. This is pretty awesome. All right, this was a longer video, but we went through a lot. Just to recap, we went through 2 complete examples with 2 separate IntelliJ projects. In the first one, we use all command line to set up a local and remote Git and GitHub repo for a Hello World project. In the second one, we had a new Hello World project, and we exclusively use the GUI tools in IntelliJ to set up a local Git repo and a remote GitHub repo. We didn't touch the command line at all. Hopefully you learned a lot. Thanks for watching.